All right, welcome back. This is Mr. Bishop once again. We're going to move forward with talking about how to solve systems with matrices now that we know how to put systems of equations into augmented matrices. So the next piece we're going to talk about is using row echelon form. So I'll go ahead and put that down here. Row echelon form, or on the streets it's just known as REF. And so row echelon form refers to our augmented matrix in sort of a simplified version, right? So let's say I had two equations and I'm going to put them into my augmented matrix. You recognize the vertical bar for the equal sign. Once I get them into row echelon form, I'll just have ones here diagonally for the coefficients and zeros underneath, and then whatever constants are left over here. So that would be for two equations in my system. If I had three equations, I'm going to need a little bit bigger matrix here. I'd have ones across the diagonal for the coefficients, zeros underneath, and then whatever the constant terms left over are. I'll just put numbers in green there. So the essence of a row echelon form matrix, it's got ones on the diagonal for the coefficients and zeros underneath. And if you're not familiar with the term echelon, it's similar to like a staircase, for example. And you can sort of see that effect here, right? If we had like a staircase coming down from the ones, right? From each row, there's an echelon, or a staircase, if you will. So how does that actually help us solve these things? Well, let's take a look at actually solving a matrix that's in row echelon form. So here's my augmented matrix. The first row is 1, 2, 5. The second row is 0, 1, -1. So you'll notice that this is in row echelon form, right? It's got ones across the diagonal here, 0 underneath, and it's got whatever these other constant terms are. So I want to know what x and y are equal to. So let's start by putting this into XYZ form. Let's put it back into a system of equations. And then I think it'll be obvious how we're going to solve this thing going forward. The first row would be 1x plus 2y equals 5. Not so bad. The second row, though, there is no x term, so I'm not going to write 0x there. All we have is 1y equals -1. So I'm going to put y equals -1 for the second equation. So already we're halfway home, right? We already know what y is equal to. Just because this last row, it was y equals this number. So we have y equals -1. That's done. All we have left to do is solve for x, and we have this equation right here that relates y, which we already know the answer to x. So we can simply just plug in -1 for this y in the top equation. So I'm going to rewrite it, x plus 2y equals 5. Notice I just leave it blank at first. I'm going to substitute that -1 in there. So that simplifies to x minus 2 equals 5. Add 2 to both sides, and we get x equals 7. So we have y equals -1, x equals 7. Or if we write it as an ordered pair, that'd be 7, comma, -1. So there you have it. There's our first example of actually solving a system using matrices. And it came from our augmented matrix being in row echelon form. So this was a bit of an easy example. It only had two variables, x and y, two equations. What if we had more variables, more equations? Say maybe 3 variables, x, y, z, or even 4 variables. How about w, x, y, z, right? Let's take a look at what row echelon would look like in that case. So my next example here, I'm going to go ahead and give you a matrix that is in row echelon form. You'll notice it's got 4 equations, right? 4 rows here. And we don't just have x, y, z over here, so we probably need another letter. How about w? So w, x, y, and z, and then of course we have our answer column there to the right. So thankfully this matrix is already in row echelon form. and ready for us to solve. Let's start at the bottom here where we have 1, so that would be 1z equals 4. So if we put this back into XYZ form, right, we already have an answer to start off with. Our last equation is going to say 1z equals 4 because all the other variables are zeroed out. Okay, so let's start with the top row there. Put this back into XYZ form. We have 1w plus 2x minus a y plus a z equals 1. There's our first equation. Our second equation, there is no w term, but we do have 1x plus 4y plus z equals 2. There it is. Our third equation is a little simpler, right? There's no w, there's no x. It's just 1y plus 2z equals 3. And then our fourth equation, like we talked about, there's our first solution. There's our first answer. We have z equals 4. Okay, so we've already got one of these knocked out. Z equals 4. And you'll notice we can actually get another answer right away if we just look up one level, right, to our next equation above that. We could actually solve for y now since we know what z is. So I'm going to go ahead and plug in 4 for z in this equation. So it's y plus 2z equals 3. Let's go ahead and plug 4 in there for z. Simplify, and we get y equals negative 5 when we subtract the 8 from both sides. All right, so now we know what z is, we know what y is. Let's work our way up the chain one more time because since we know z and we know y, we could easily plug in those values and get our answer for x. So if we go up the chain one more time, let's see. X plus 4y plus z equals 2. That's what this equation says. I'm going to leave these blank right now because I know I'm plugging in negative 5 for y and 4 for z. We simplify and get x by itself. We get x equals positive 18. So there we go. We've solved for 3 of the 4 variables. We've got 1 to go, so it's time to go to that top level. Since now we know what x, y, and z are, we can plug those values in that top equation and get our answer for w. So the top equation is w plus 2z minus y, w plus 2x minus y plus z equals 1. So let's plug in the values that we know. We know x is 18, y is negative 5, z is 4. Simplify that and get w by itself. We have w equals negative 44. So there you have it. If I write my answer as an ordered quadruple, if you will, w, x, y, z, negative 44, 18, negative 5, and 4. All right, so now we know about row echelon form. We know how to convert those to XYZ form, and then starting with the bottom answer, plug that in and work our way up the chain, whether we've got 4 equations or whether we've got 2 equations or however many equations we have. That's how we can solve these matrices using row echelon form. How do you get your matrix into row echelon form? Using your calculator. So I picked the last question on the day 4 worksheet, number 57 here to talk about. For starters, we need to put it into an augmented matrix and then put that augmented matrix into our calculator. So number 57 in augmented matrix form, let's see the first row, 1, 1, 4, and 3. The second row, 4, 1, negative 2, negative 6. And the third and final row there is a negative 3, 0 for the y, there's no y term, 2, and 1. Okay, so now I need to tell my calculator about that matrix so we can actually do the math and move forward with row echelon form. So I'm going to go to second matrix, this little X with a negative 1 on it, right? And it might as well be matrix A, right? So I've already entered it in matrix A, but to do that, let's go over here to edit, arrow over a couple times, hit enter, update the dimensions to a 3-row by 4-column matrix. And then you can type in each entry from there. Okay. So once you've told your calculator what the matrix is, let's go back and run some operations on it. So I'm going to go back to the home screen, which means I'm going to do second quit. So here I am back at the home screen. Now your calculator has a lot of matrix operations that it can run, or matrix math, if you will. But we have to go back to the matrix menu. So I'm going to hit second matrix again. And instead of clicking on a specific matrix, I'm going to go over here to math. And there's a lot of different things it can do under the math category. I'm going to scroll down here. We want to put it in row echelon form for now. So REF, there it is, row echelon form. Your calculator's like, okay, what do you want me to put in row echelon form? That's what it's asking me right now. Well, I want you to put the matrix that I just typed in into row echelon form. So let's go call up that matrix. Let's go click on matrix A and select it. So second matrix A, hit enter, there it is. So now you're telling your calculator, I want you to take matrix A and do row echelon form. So let's just hit enter and see what happens. Lovely, there it is. We've got the ones across the diagonal, the zeros underneath. So I'm going to go ahead and write that down. So row echelon form of this ends up being ones across the diagonal. So 1, 0.25, negative 0.5, negative 1.5 for that first row, 0, 1, 6, and 6 for the second row, 0, 0, 1, and 2 for the third row. And now your calculator's done the hard work for you. All you have left to do is solve the systems, right? And for example, we already know with this last equation, 1z equals 2. So z equals 2. There's our first answer. Now we just have to put these into Xyz form and we can plug in and solve from there, just like we talked about in the last video. Okay, that's all for this calculator demo, putting a matrix into row echelon form. You can take it from here. Thanks for watching.